reinforcement learning. So when we consider the different kind of machine learning algorithms, we can categorize them as supervised, unsupervised, and reinforcement. So in supervised learning, it is task driven. We can predict the value of some data. Okay, the output we can predict, and in unsupervised data, it is unsupervised learning. It is data driven. Then basically it identifies some patterns in the data, or it can identify the clusters. In reinforcement learning, the system learns from mistakes. So that is how the learning algorithms are categorized. And today we are going to see reinforcement learning. In supervised learning, we actually give a feedback to the system, and we know the original output, and we know the predicted value, and the difference between these two are called as lows. Okay, and we try to improve, or we try to modify the rules in this system, or the parameters in the system, in order to reduce this loss, or in order to reduce the difference between the prediction and the actual value. That is happening in supervised learning because we know the original value. Okay, apart from the predicted value, we know the actual value. So since we know that, we can make these kind of changes in the system. Okay, so that is supervised. And then unsupervised, there is only features or the data fed into the system, and this unsupervised learning algorithms will try to find out some pattern out of this data. They don't know much about the data, but they try to analyze each data or compare each data, and dig out a pattern from that data. That is unsupervised learning. Then when it comes to reinforcement learning, it is working based on rewards. That means if the system interacts with the environment, and when the actions are good, when the actions of the system are good, it will get rewards. Otherwise, it will get penalty. Okay. So using this reward and penalty, it understands that okay, this has to be done and this should not be done. So it's a learning process by interacting with the environment. Okay, so these three are the learning systems. And how RL is the short form of reinforcement learning. RL is different from supervised or unsupervised learning. There is no supervisor to guide the training. That is the main difference in RL, and in unsupervised also it's like that. You don't train with a large labeled or unlabeled pre-collected data set. In supervised and unsupervised, we can train the system, but that kind of training is not there in RL. Rather your data is provided to you dynamically via feedback from the real world environment with which you are interacting. So our system is interacting with the environment, and from this interaction it understands that this is good and this is bad. You interactively make decisions you iteratively make decisions over a sequence of time steps. Example, in a classification problem, you run inference once on data input to produce an output prediction. With reinforcement learning, you run inferences repeatedly, navigating through the real-world environment as you go. Okay, so we are not iteratively running through the same data. Instead, we are working with the real-world environment, and that interaction that teaches the system that is which one is good and which one is bad. So learn from the environment. A typical example is like this: if the baby, you consider a baby, if we give him the freedom to interact with its environment, if we have a fire over here and bottle of milk over here, he can interact with these two and can understand that this one is the okay, milk is good and fire is bad. Okay, so when it do when the good things happen, we give a feedback with a reward. Okay, so like a positive number, and if there is any bad events, we'll give a penalty like a negative number. Okay. So that's how that means the baby interacts with the environment. It interacts with two things in the environment. One is a bottle, milk bottle, and the other one is fire. And from his interaction, he understands that this is good and this is bad. So reinforcement learning is a type of machine learning technique that enables an agent, agent in this case it's a baby, an agent to learn learn in an interactive environment by trial and error using feedback from its own actions and experiences. Okay, so for some actions the system gets reward, and for some other actions they get a penalty. So based on this rewards, it understands that okay, this should be continued and this should not be continued. Though both supervised and reinforcement learning use mapping between input and output, unlike supervised learning where the feedback provided to the agent is correct set of actions for performing a task. Okay, in supervised learning, we train the system with the actual data and let it predict the value and compare those two values, and it can correct it if the values are not matching. So in reinforcement learning uses a reward and punishment signals for positive and negative behavior. For positive behavior, they get a reward, and for negative behavior, they get a punishment. Positive behavior, like the baby gets the milk bottle, so that is a positive thing, and gets to fire is a negative behavior. Okay. So, as compared to unsupervised learning, reinforcement learning is different in terms of goals. While the goal in unsupervised learning is to find similarities and differences between data points. It finds out the clusters in the points or the pattern in the point. In the case of reinforcement learning, the goal is to find a suitable action model that would maximize the total cumulative reward of the agent. So in the case of reinforcement learning, it has to learn some actions. It has to find out some actions that improves its rewards and reduces its penalties. Okay, so the purpose of these two things are different. For unsupervised and reinforcement learning, the goal itself is different. So an action reward feedback loop for a reinforcement learning system can be drawn like this. The agent interacts with the environment. Agent and environment are the two main components here. Agent interacts with the environment through its action. Agent do some action in the environment, or it interacts with the environment using action, and for the output of this action will be some kind of reaction in the form of the changing state and the reward or the penalty. R is the reward and S is the state. Okay, and let's see what are these components. Environment is the physical world in which the agent operates. Environment, that is the actual physical environment. In the case of Mars rovers, we send the Mars rovers to Mars, and the actual environment is the environment in Mars. Okay, the physical environment there. Then state the current situation of the agent, or its position, current position, or okay, like that. What is the current status of the agent? That is the state. Reward is the feedback from the environment. If the reward is positive, we say that it is a good thing, good action. If it is the reward is negative, we say that that's a negative action or it's a bad action. It should not be repeated anymore. Then agent is the system that we talk about. That is the AI system. that is agent. That is in the case of Mars rover. So Mars rover is the agent. For example, the robot. This is the model that you want to build and train using the RL system. Policy is the method to map the agent state to actions. So current state and what should be the next action. So that mapping is called the policy. Value is the future reward that an agent would receive by taking an action in a particular state. So if it is in a particular state and if it takes this action, what will be the reward? That is the value. And that is suppose this is our robot or our agent and it interacts with an environment in a system, and after this interaction or after this action, what will be the state of the agent, what will be the reward from the environment, or whether it is positive or negative. So when we elaborate on environment, it's a physical world in which the agent operates and the real world environment with which an agent interacts as part of its operation. So it may be interacting with other human beings, or it may be interacting with the other objects. Okay, anything, any obstacles in front of the robot, everything is part of the real world. Examine the terrain that the robot has to navigate, its surroundings, factors such as wind, friction, lighting, temperature, and so on. Everything will be taken as the environment. And the state, this represents the current state of the world at any point, or state of the, or we should say that it is the state of the agent. Okay, or it could be it could capture the position of the robot relative to its terrain, the position of the objects around it, and perhaps the direction and speed of the wind. Everything is called as the current state of the environment and current state of the agent. There could be a finite or infinite set of states. Okay, in some games and all, if you use some robot for a game, soccer game and all, the states are finite. Okay, we can define a set of states and the robot can be in. But in the case of a Mars rover, we cannot identify all the states. So that is a infinite set of states can be there. Action is these are the actions that the agent takes to interact with the environment. That is, the robot can turn right or left, move forward or backward, bend or raise its hands, and so on. So these are the actions by the robot. Okay, actions by the robot. So there could be a finite or infinite set of possible actions. Then the next one is reward. It is the positive or negative reinforcement that the agent receives from the environment as a result of its action. It is a way to evaluate the goodness and badness of a particular action. If moving in a particular direction causes the robot to run into a wall, that would have a negative reward. On the other hand, if turning left causes the robot to locate the object it needs to pick up, it would get a positive reward. Okay, so for positive action, positive reward. For negative action, it's a negative reward. So it will identify, it will learn that this is the right thing and this is the wrong thing. Then Q learning and SARSA. SARSA is the state action reward state action cycle. Are two commonly used model-free reinforcement learning algorithms. They differ in terms of their exploration strategies, while their exploitation strategies are similar. While Q-learning is an off-policy method in which the agent learns the value based on action, A star derived from another policy, SARSA, is an on-policy method where it learns the value based on its current action derived from its current policy. The characteristics of reinforcement learning. There is no supervisor only a real number or a reward signal in reinforcement learning instead of the supervisor. There is a sequential decision making based on the actions and reward. Time plays a crucial role in reinforcement problems. Feedback is always delayed, not instantaneous. Agent's action determine the subsequent data it receives. Okay, based on the interaction with the environment, it gets the next data. The data is not predefined. Then types of reinforcement learning. Two types of reinforcement learning methods are there. One is positive and the other one is negative. And in positive learning, it is defined as an event that occurs because of a specific behavior. It increases the strength and frequency of the behavior and impacts positively on the action taken by the agent. This type of reinforcement helps you to maximize the performance and sustain change for a more extended period. However, too much in reinforcement may lead to over optimization of state, which can affect the results. And the second type is negative. Negative reinforcement is defined as strengthening of behavior that occurs because of negative condition which should have stopped or avoided. It helps you to define the minimum standard of performance. However, the drawback of this method is that it provides enough to meet up the minimum behavior. That means we have to find out, or we have to define all the negative behaviors, and the agent should encounter all these negative behaviors. So we have to anticipate all the negative behaviors. So that is all about the reinforcement learning types, positive and negative. Then learning models of reinforcement. That is, one model is Markov decision process and the other one is Q-learn. We are not going deep into these two topics. Okay, then the applications of reinforcement learning. Robotics for industrial automation, business strategy planning, machine learning and data processing. It helps you to create training systems that provide custom instruction and materials according to the requirement of the students. Aircraft control and robot motion control.